Hey everyone, this is John Oden on the development team here at Boson Software, and welcome back to our 7th video in this series of video presentations entitled Subnetting Demystified. Now, in the first 6 videos, we have covered some foundational information about IP addressing and binary math, classful networking, classless networks. We talked about in the previous presentation, why do we subnet, what needs drive us to be able to do these subnet manipulations and calculations. So now we're actually getting to the point that we need to get into the nuts and bolts of how to take a given piece of the IPv4 address space and break it down into smaller pieces. And that's exactly what we're going to do here in this presentation, Subnetting How To. So let's go ahead and get started. Let's take a moment to refer back to this diagram that we developed in our prior presentation. This is a network topology that we've been working with throughout this series of videos, and we've developed it along to the point that we talked about how many hosts are required at each of the 3 local area networks that make up the topology that we have. And we also were reminded that each of the WAN links that connect our locations together are also networks, and we need to consider those whenever we create our IP addressing plan for the topology. So up here we can see that we were given the 192.168.10.0/24 network. That's the network space that we're given to work with, and it's up to us to use subnetting practices to be able to take that piece of the IPv4 address space and chop it up into some number of subnetworks that will satisfy the IP addressing requirement for the topology that we see here. So since this is a /24, we know that we have these first 3 octets. The first 24 bits are fixed. We can't change or manipulate those in any way. The last 8 bits in this given address block are ours to work with, and we're shown here that we have some number of hosts that are required in each of the networks that we're going to configure, and in our last video we worked through the number of host bits that would be required for each. So here in location 2 up here at the top, we were given a requirement to support 50 hosts on that network, and we went through and did the binary math and saw that if we take 6 bits, that's 2 to the 6th power, that's 64, we take away the 2 special cases, the all zeros value, which represents the network ID for that subnetwork, and then the all ones value in the host portion of the address, which represents the broadcast for that network. And we see that with 6 bits for host, we can support 62 hosts on that network. We're required to support 50, and that's just fine. So over here in location 1, we were required to support 25 hosts, and we see that 5 bits would be sufficient for that. 2 to the 5th is 32, minus those 2 special cases would give us the 30 addresses that we need. And then finally over here in location 3, we are given the requirement to support only 10 hosts. And looking at that from a binary standpoint, we can take 2 to the 4th power, 4 bits for host, and that gives us the ability to support 16 minus 2, or 14 usable host addresses. This is just all review from our last presentation. Be sure and go back and watch that if you haven't seen it already. We're just developing on those ideas. Now, as far as the wide area network links are required, remember that these are point-to-point links. We'll need to provide for 1 host IP on each end of the link. So these are 3 little networks that we only have to have 2 hosts in each one. So if we allocate 2 host bits there, 2 to the 2nd power is 4, minus the 2 special cases, the all zeros value for the network ID, the all ones value for the broadcast, and that gives us exactly the 2 hosts that we need for each network. So we'll have 1 for there, 1 for here, and 1 for here. We can see that it's not always going to be a perfect fit. We have to be able to support at least the number of hosts that are required. We can't come up with a scheme that supports fewer than the specified numbers of host IP addresses that are required. But in some cases, it's okay if we have a few more. For example, here in this larger location where 50 hosts are required, if we had only used 5 bits for the host portion, that would give us only 32 hosts, which would not be sufficient for the requirement. Going to 6 bits, that gives us 62 hosts. That's a few too many, but now we've got a little bit of room to expand. With regard to these point-to-point networks, they're never going to have more than 2 host IP addresses on them, so the fact that using 2 bits for host addressing in these little small networks doesn't really bother me too much, because I know that that point-to-point link is never going to have more than the 2 host IPs that configuration gives us. So that's a little bit of a review and a recap of what we've come up with so far as the requirements for this network topology and its IP addressing scheme that we're getting ready to dive into and start to work through. So on the whiteboard, you can see the 192.168.10.0/24 network that we're given to work with. You can also see the requirement for 50 hosts. Now, when I'm working through these IP addressing plans like this, I like to begin with the largest subnet first. So you'll recall from the topology that we were just looking at a moment ago that the location number 2, which required 50 hosts, that's the largest subnetwork that's required. So we're going to go through that one first. Notice also that I have written all of this out in binary so that we can see each octet and what it looks like in binary. I've also written the bit weights above the top of each bit position in each octet, just to make it easy when we start doing a little bit of counting. And also down below, you'll see that I've written out 4 points. And anytime you are working through a subnetting problem, or you're given an address block and asked to do some sort of subnetting manipulations, you'll always want to keep the 4 following questions in mind. These are the 4 things that you're always going to be solving for. First, what is the network ID or the network number? Next, what is the usable host IP address range? In other words, what is the first IP address that we have available for assigning to a host device in that subnetwork? And what is the last IP address that we have for assigning to a host in that subnetwork? And everything else in between that's the usable range. The ranges are contiguous, so we'll have first host and last host. Next, what is the broadcast ID number for that subnetwork? And that's going to be, if you'll recall, the other of our 2 special cases. This is the first special case up here. What is the network ID? That's where we have all of the host bits set to 0. Or what is the broadcast? Well, that's where we have all of the host bits set to 1. So we need to see what that is. And then finally, we'll want to figure out what is the next network ID, or the next subnetwork ID, I guess I really should say. That's what we're trying to solve for. What is the subnetwork ID? What is the usable host IP address range within that subnet? What is the broadcast ID for that subnet? And what is the next subnet ID? In our previous presentation, you'll recall I mentioned that we're going to start working with 3 kinds of bits. Up to now, we know that we have had network bits and we have had host bits. And in this particular example, we can see that we've got 192.168.10.0/24. So I'm going to highlight these first 3 octets, and those are our network bits that are given to us. We can't manipulate those in any way. And for this particular example, we determined that we needed 6 bits to be able to accommodate at least 50 hosts. And there are our last 6 bits. I've highlighted those in green. These are the 6 bits that will represent our host IP addresses. And right here in the middle, these are this new category of bits that we'll start to talk about. These are our subnetting bits. These are the bits that will identify each subnetwork that we'll create when we start breaking down 192.168.10.0. So I've started to work in binary here just to show you how it looks as we count through the host IP addresses in this first subnetwork. So once again, the highlights, I've used red to highlight the first 24 bits that can't be changed because that's what was given to us. We've got the last 8 bits to work with, and based on our specification to be able to cover 50 hosts, we know that we've got to have 6 of those 8 bits for host IPs, and I've highlighted those in green. And then our subnetwork bits are the other 2 that remain. So our first host is going to be host number 1, and if we were to write that out in dotted decimal, that would be 192.168.10.1. So we can see the 1 bit is turned on here. For the next host, we turn the 1 bit off and the 2 bit on. So this one is 192.168.10.2. And then for the next one, we leave the last 2 bits on. We turn the 1 bit on and the 2 bit on to give us a total value of 3 for the host here. This is our third host, which would be 192.168.10.3. In the next one, I've turned the last 2 bits off, and I've turned the 4-bit on. So we have 192.168.10.4 as our 4th host in this subnet. Now, I'm not going to take your time up by writing out all of them, but I've put 3 dots here to show that that's the continuing series all the way down to where we have the 32-bit on, the 16-bit on, the 8-bit on, the 4-bit is on, and the 2-bit is on, and this last bit is off. So what is the value for that if we add all of those up? Well, we can take 32, 16, 8, 4, and 2 and add all of those together, and I bet we'll get 62. Why did we stop at 62? Well, the next number in the series would be the number that we get if we were to set all of those last 6 bits to 1, like that. Now, is that a valid host IP address? Well, our rules say no, because that's the other special case. So let's see if we can answer those 4 questions that we posed in the beginning. First, what is the subnet ID? Well, we take what we're given, which is 192.168.10.0, and we set all of the host bits to 0, and that is our first subnet. So what is that? Well, that's what we see right here. 192.168.10.0 is our first subnet. But is our first subnet 192.168.10.0/24? Well, no, it's not, because /24, that's the whole thing. That's what we were given. Our first subnet, and I'm out of room, so I'm going to write it down here below. Our first subnet here is 192.168.10.0 slash what? /26, right? Because we're using 2 subnet bits, and we move the dividing line for this first subnet, and actually all of the subnets that we're going to do like this, over to the dividing line between the 26th and 27th bit. So what is the usable host IP address range? Well, we've drawn it out here in binary. We've taken our subnet ID, which is 192.168.10.0/26, and we always take the subnet ID and we add 1 to it. In this case, the subnet was 0, so we add 1 to it and we get 1. So our first host IP is 192.168.10.1. Then our next one, I drew it out in binary. It's 192.168.10.2, 10.3, 10.4, and so on all the way down the line until we get to the place where all of the host bits except 1 are set to 1. Remember, we have that other special case where all of the host bits are set to 1, and that answers the third question, what is the broadcast number? So the broadcast number, let's go ahead and figure that one out. That is where we take all 6 host bits and set them to 1. So if we take 32, 16, 8, 4, 2, and 1 and add all of those up together, we get 63. And that's the broadcast ID for this subnet. So what is the last host in the range? Well, the easy way to figure that out is to take the broadcast ID and subtract 1. So that's what it looks like in binary right here. If we take 63, which is the value that we get with all of the host bits set to 1, and we subtract 1 from that, then we get 62. And I've drawn that one out in binary so that you could see it. And that is the 32, 16, 8, 4, and 2 bits are set on. The 1 bit is set off because that's 1 less than the broadcast. So our usable host range is 1 plus the subnet. Subnet is 0, so we've got 1 here. Our last host is 1 less than the broadcast. The broadcast is 63 because that's what we get if we add up the bit weights of all 6 of these host bits. So the broadcast is 63, minus 1 is 62, and we can just kind of do a little sanity check here by looking at the bits and seeing if we add up 32, 16, 8, 4, 2, and 0, we get 62, which is our last host in the range. Now for the final question. We've answered the first 3 questions. The final question that is posed by these 4 points on the whiteboard, what is the next subnet? Now this thing that I'm getting ready to show you right now, if there's one pivotal point that if you can make sure that you understand what's getting ready to happen here, this will immensely improve and make much easier your journey through subnetting. So let's work through this. Let's actually just review kind of where we came from. What is the subnet ID? Well, how do we get that? We started out by taking what we were given, which is 192.168.10.0/24, and we recognized that we needed to be able to accommodate 50 hosts. We've talked about a couple of times now that takes 6 bits to be able to cover at least 50 hosts. It actually covers 62. We've already seen that. 62 is more than 50, so that's enough. So in the highlighted colors here, I've taken green and highlighted those last 6 bits, which are our host bits. And we know that if we take all of the host bits and set them to 0, that is the current subnet ID. So our current subnet ID for this first subnet is 192.168.10.0 slash, not slash 24, but slash 26, because we've moved the line over 2 bits because we need 6 bits for host, and that leaves these 2 bits that I've highlighted in yellow to identify the subnetworks, to provide the subnetwork ID. So what is the subnet ID for this first subnetwork? 192.168.10.0/26. And then the next thing that I like to consider is what is the usable host address range? Well, we take the subnet ID and we add 1 to it. So in this case, our subnet, everything was 0, so we added 1 to it. That's really easy. So the first host is 192.168.10.1. What is the broadcast ID? Well, that's where we set all of the host bits to 1, and I've done that down here. Our subnet bits are still 0s, so all of the host bits now are set to 1. That's as far as we can go in this subnet because we've got nothing else to set to 1. We've already set everything to 1. So the broadcast ID is the highest value that we could have in this subnet. So if we take all these bits and add their bit weights together, do the binary to decimal conversion, 32, 16, 8, 4, 2, and 1 all added up together is 63. So our broadcast ID for this subnet is 192.168.10.63. So what is the last host? Well, it's easy to figure that by taking the broadcast ID and subtracting 1 from it. And I've drawn that one out in decimal so that you can see what that would look like. And that would be 192.168.10.62. And there it is right there, 192.168.10.62. That is the last host. And this next value is the broadcast. Okay, now here we go. What is the next subnet? Well, the next subnet we know it's going to be a subnet value. So what does that mean about the host IPs? We've got to set all of those to 0. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. There goes all of our host bits set to 0. So what's the next subnet? Well, in binary, it's going to be what? That, right? So that is our next subnet. We take the next bit that we have, which is this bit right here, and we set it to 1, and we set the bit in front of it to 0 because we're just incrementing to the next subnet. Our prior subnet was 0, 0 in binary, so our next subnet with respect to these 2 subnetting bits is 0, 1. So what is the decimal value for that? Well, we've got to look at the bit weights. What is the bit weight of this position right here? This is position number 2 if we're counting over from the left. So if we look at the top here, we can see that the bit weight for that bit is 64. So I've cleared a space out to write down here. So let's write our next subnet ID. We just look at the binary and we can see what it is. We know the first 3 octets don't change. What we have highlighted in red, those are the first 3 octets, and those will always be the same. So let's go ahead and write those down. 192.168.10 dot what? Dot 64, right? Because that's the value we get if we took this last octet that we have and converted it from the binary that we have to the decimal. And it's going to be like that. So the first subnet was 192.168.10.0/26. This is the second subnet, which is 192.168.10.64/26. So that answers all 4 of the questions that we have posed. Okay, here we are with the second subnet. And we started with subnet 0. That's when both of our subnet bits were set to a value of 0. And our subnet ID at that time was 192.168.10.0/26. So as you just saw, we worked through and we figured out what the host range and the broadcast and so forth for that subnet was. So now we have set our first subnet bit to value 1. And as we said, that first bit in our subnet, that least significant subnet bit, has a bit weight of 64. So what's our subnet ID now going to be? Well, as we've also already said, it would be this: 192.168.10.64/26, right? Because we're allocating the last 6 bits for host and the other 26 bits for network and subnetwork ID. So what's the host range going to be? So what will be the valid host IP address range? Well, we can figure that out just like we figured it out before. When we set our first host bit to 1, then what does that value become? Well, in our previous subnet, it became simply 1 because all of the subnet bits were 0. But now we have one subnet bit in the 64's position set to 1, so we have to take this entire octet in its entirety, even though it's composed of some subnet bits, 2 subnet bits, and host bits, 6 host bits. When we figure out what is that first host ID, we have to add up the value of all 8 of these bits. So we've got 64, and 1 is 65. So our first valid host is 192.168.10.65 through, and what's our last valid host in this subnet going to be? Well, we can go down here and look at the bits. The definition of the last host is going to be the situation where we've got all of the host bits set to 1 except for that last one, and we can just add up the bit weights. So we add 64, which is our subnet bit, and then all of the host bits except for that last one that's 0 because that's our last host: 32, 16, 8, 4, 2, and 1, and we get a value of 126. So our last host, 192.168.10.126. And what's the broadcast? That's simply the situation where all of the host bits are set to 1. We've got to consider our subnet bits. So if we take 64, 32, 16, 8, 4, 2, and 1, and add all that together, here's our broadcast. For this subnet is 192.168.10.127. Now, as you start to pick up speed with your work and you learn how some things work a little bit better than others, what you may learn is that it's easiest to figure out what is the subnet ID. And then if you know what the subnet ID is, you just add 1 to it, and then that gives you the first host. Then figure out what's the next subnet ID going to be, and subtract 1 from that, and that gives you the broadcast of the previous subnet, and then subtract 1 from that, and that gives you the last host. Now we'll do a bunch more of these, and you'll see this pattern repeat itself over and over, and that'll help you get faster as you work through these. So what's the next subnet ID going to be? Well, we just look at the bits. The current subnet is subnet 64, and in binary that's 01. So if we were to go to the next binary increment, the next increasing increment with respect to the 2 subnet bits here, what's it going to be? It's going to be this, right? 1, 0. So if we add the bit weights up, we can look and see that the bit value for that bit that we just set to 1 is 128. So then our next subnet is going to be, and notice also I've written yet another thing that we need to determine down here. What is the decimal subnet mask? We've been talking in slash notation so far here. We've talked about the fact that our first subnet was 192.168.10.0/26. Our next subnet was 192.168.10.64/26, and so on. So what is the subnet mask for that? Well, let's remember what the subnet mask is. It is a value where we set everything to 1 up to the point where the host bits start. So the subnet mask is going to be 26 bits of 1s. So if we take these first 3 octets and set them to all 1s, let's go ahead and write down what we know. We know that an 8-bit octet where all of the bit values are set to 1 is 255, right? So 255.255 192.168.10.192.255. That represents this portion that we've shaded in red that represents the network that we're given. So remember, this is a subnet mask. This is not an IP address we're calculating here. So we need two more ones to cover these subnet positions. So if we take those bit weights and add them together, 128 and 64, then that gives us a value in the last octet of the subnet mask of what? 192. So a /26 prefix, when expressed as a decimal subnet mask, is going to be 255.255.255.192. So what's the next subnet going to be? Well, you can see I've gone ahead and written in the binary value. Our first subnet was 00. Our next one after that was 01. So here we are with a subnet of 10. Let me draw your attention to this value right here. You can see the bit weight that I'm highlighting is 64. And this is a very important number. This number is the subnet interval. Do you notice that the first subnet was subnet 0? The next subnet ID was subnet ID number 64. That's 192.168.10.64. The first one was 192.168.10.0. The next one was 192.168.10.64. What's this one going to be? 192.168.10.128, right? Because we've got a 1 in this position that has a bit weight of 128 and a 0 in the next bit position for the subnet. This number is often referred to as the subnet increment, or the decimal value by which the subnet IDs increase as you walk through the subnets and figure the host ranges and the broadcast IDs in the next subnets. Some subnetting tutorials refer to this as the magic number because it is in fact quite magic. If you can understand how to quickly determine what that number is, this leads you to the place where you can start to do all of this much more quickly. In many cases, you can even do it in your head once you learn what's going on without having to write down all the ones and zeros and everything that you see me putting on the whiteboard here. You can just start writing it down, and I'll show you how to get to that place a little bit later on. So given that, let's go ahead and skip ahead and figure out what the next subnet is going to be. Our first subnet was 00. I'm talking in binary here. Our next subnet after that was 01. And this subnet, the one that we're currently working on, is 10. What's the next one going to be? Well, it's going to be 11, right? So when the subnet bits are 11, then what would the subnet ID be in that case? It would be that value right there, 192.168.10.192. And how do we get that? Well, we got it by adding the bit weights of the two subnet bits together, 1 and 1. One of those bits has a weight of 126. The one next to it has a weight of 64. So that gives us our next subnet ID of 192.168.10.192. So if you can figure out what the current subnet ID is, which we know it's .128, we know what the next subnet is, .192, then everything else just kind of falls into place, because if we can take the current subnet ID and add 1 to it, then that gives us our first host IP address in the subnet, 192.168.10.129. So if we know what the next subnet is, it's very easy to figure out what is the broadcast ID of the current subnet. We just take our next subnet, 192.168.10.192, and subtract 1 from it. And to get the last host IP address in the range, we take the broadcast and subtract 1 from that, giving us a last host IP of 192.168.10.190. So let's see what this subnet looks like. We saw already that our next subnet, when we were working on the previous subnet, the next subnet, which is now the current subnet, had a binary value of 11 with respect to the subnet bits. So we added those two values together, 128 and 64, and that gives us our current subnet ID, 192.168.10.192. So our first valid host is going to be that plus 1. Notice I didn't put a next subnet down here because there isn't one. This is the end of the line. We started with 00, then 01, then 10, and then 11. There can only be 4 subnets here. We've got 2 subnet bits. 2 to the second power is 4. We don't do the -2 with subnet bits and network bits like we do with host bits, because there are no special cases for all ones and all zeros. All ones and all zeros are valid subnets. So we can take the current subnet ID, add 1 to it, and get the first host in the range. And then to get the broadcast, we can just look down here. There it is. That's the broadcast, and that's just with both subnet bits set to 1 and all of the host bits set to 1. So what that's going to be is 192.168.10.255, right? If we have an 8-bit value and all those bits are set to on, then that gives us decimal 255. So what's our last host in the range going to be? Well, it's going to be that broadcast minus 1. So our last host is going to be 192.168.10.254, which is 1 less than the broadcast. So remember that being able to figure out what the subnet increment value is, and that's that value, that's the bit weight of the least significant subnet bit. This is the value by which the subnet IDs will increment. That bit weight for that position is 64, so our first subnet was subnet 0. Our next subnet was 0 plus 64. Our next subnet was 128, which is 64 plus 64. Then the next subnet after that was 192, which is 128 plus 64. So we can see that those subnets are incrementing by this bit weight right here of 64. If our subnet mask is further over, this is a /26 we're dealing with here. If we were dealing with a /28, then the increment would be right here. It would be incrementing by 16. And we'll see some examples of some of these smaller increments as we continue to work through the IP addressing plan for our topology. So let's look at breaking this down in a little bit more of a concise way. From the network specification that we were given, we were told that we needed to accommodate 50 hosts. We determined that that requires 6 host bits, 2 to the 6th, 64 values minus our 2 special cases, 62 hosts. That's just about the right size. So 6 host bits, those are the green bits here. So we put our dividing line right there, which is a /26. And we learned about this idea of a subnet increment, which is the bit weight value of the least significant subnet bit. And that's the rightmost subnet bit, which in this case is this one right here that has a bit weight of 64. And that tells us that our subnets are going to increment in decimal by a value of 64. So let's go ahead and just write down the 4 subnets that we're going to have. There's our first one, 192.168.10.0. Then we'll add our increment to that to get the next one. And then to get the next subnet, we'll add our increment to that, which gives us 192.168.10.128. That's the subnet ID for our third subnet. And for our fourth and final subnet, we take the prior subnet ID and add the increment to that, which is 128 plus 64. That gives us 192.168.10.192. And that's the last subnet. Well, how do we know it's the last subnet? Well, if we look at the number of subnet bits that we have 2. So if we take 2 to the 2nd power, that's 4, and that tells us that there are going to be only 4 subnets. So even though this is not a valid next subnet, I'm going to go ahead and write the number down here, and you'll see why in a minute. I'll take 192 and add 64 to it. That's 256. That's not the next subnet, but having that number down there will make it a little bit easier when we get to our next steps here. So maybe you can see where I'm going here. I'm going to go through and figure out what is the broadcast ID for each of these subnets. And I'm going to do it by taking the next subnet and subtracting 1 from it. So right now we're considering the current subnet, which is 192.168.10.0. Our next subnet is 192.168.10.64. So our broadcast for this first subnet is 1 less than the next subnet. So that'll be 192.168.10.63. What about for the next one? Well, it will be the next subnet, which is 192.168.10.128. We'll subtract 1 from that and get the value 192.168.10.127, which is the broadcast for this subnet. And then just moving right on down the line, 192.168.10.128 192.168.10.191. That's going to be broadcast for the 128 subnet. And then finally, for the last one, and you can see where I wrote that 256 down there, I can just take 192.168.10. 256 minus 1 is 255. That's just kind of a reminder of how it always all works out. So the broadcast for this last subnet, for the 192 subnet, is 192.168.10.255. So if we know what all of our subnets are, and we know what the broadcast ID for each subnet is, then it's very easy to figure out what is the first host and the last host. The first host is always going to be the subnet plus 1. So we can just go right down the line. For the 0 subnet, the first host will be 1. For the 64 subnet, the first host will be 65. For the 128 subnet, the first host will be 129. For the 192 subnet, the first host will be 193. What about for the last hosts? Well, if we have the broadcast, then we know that the last host IP is 1 less than the subnet broadcast. So if the broadcast is 192.168.10.63, then our last host is going to be 62. The last host for the next subnet, the 64 subnet, its broadcast is 127, so the last host is going to be 126. And don't let me confuse you with my shorthand here. I'm just writing down the value of the last octet because everything is 192.168.10. something. So this first host is 192.168.10.1. The last host is 192.168.10.62. The broadcast, of course, is 192.168.10.63. So for the 128 subnet, our first host IP is 129. The last host IP will be 1 less than the broadcast. The broadcast is 191, so our last host IP will be 190. And for the fourth and final subnet, subnet 192, our last IP is going to be 1 less than the broadcast. The broadcast is 255, so our last, or the value, the decimal value of the last octet for the last host IP in the last subnet is 254. So for any of these numbers that I've written down just the one number, this is the value for the fourth octet, and just be sure and stick a 192.168.10 in front of it. I would have written it all out, but I'm a little bit short on room, and it just makes it a little easier to read this way, I think. So now that we've taken 192.168.10.0/24 and broken it down into 4 subnets, what are we going to do with that? Well, what we're going to do is we're going to take the first subnet and assign it to location 2. Why location 2? Well, I just find that it works better if we take our biggest location and we subnet our given IP address space into subnets that are appropriate for the largest location. And let's go ahead and take the first of those subnets, and I'm just going to write it up here and assign it to location number 2. So we've taken the 192.168.10.0/26 subnet and assigned that to location 2. So what about the other locations and the WAN links? Well, we're going to take the next subnet, which is 192.168.10.64/26, and now we're going to see how to subnet a subnet. We're going to take one of the remaining 3 subnets, the next one, the 64 subnet, and we're going to then in turn break it into pieces so that we wind up with additional subnets, if you will, that are appropriate for these other 2 locations and for the WAN links. Okay, so here we are, ready to subnet a subnet. Now, just to take inventory of how we got to where we are, we took 192.168.10.0/24 in our last series of procedures, and we chopped that up into a series of 4/26 subnetworks, of which the one I've got on the whiteboard is the second. The first one, 192.168.10.0/26, we assigned that subnet in its entirety to location 2, which requires 50 hosts. Now, this is the second subnet, and we're going to divide it further. We're going to subnet a subnet so that we wind up with one subnet that we will assign to location 1, which requires 25 hosts, and then the remaining subnet will assign over to location 3, and then we're going to see in that exercise we're actually going to subnet the subnet of a subnet, and that will give us a little bit of space left over even still to account for the WAN links between the 3 locations. So let's go ahead and press on. I'm going to write this out in the more concise way that we started using in our previous procedure. So to get started, let's examine what's going on with the bits in the last octet. And the first thing that we need to do is to figure out what is our first subnet ID going to be. So let's go ahead and do that. Remember, the subnet is where all of the host bits are set to 0. So let's write that out. Note here that we have now 5 subnets. Notice here that we have 5 host bits. 1, 2, 3, 4, 5. We have only 1 subnet bit, and the last 2 are part of the subnetwork that we are further dividing. You can see that which we cannot change I've got highlighted in red using the same scheme that we used before. Our subnet bit, and only one subnet bit in this case, is yellow, and our host bits are green. So the resulting subnet is going to be what? It's going to be a /27, because if you count over from the very beginning of the 32-bit value to this blue line here, which denotes the dividing line between hosts and subnet and network portions of the IP address, you'll see that we are 27 bits over from the left. So the resulting subnets we're going to come up with here are going to be /27s. So what is the subnet ID for our first subnet going to look like? Well, here we go. I've set our 5 host bits to 0 because that's the definition of the subnet ID. And our subnet bit at this point is 0. So we'll just bring that down. In this 0.01, that's the last 2 bits of the network that we're subnetting. So we just bring that down. And if we look at the value that we wind up with here, it's all zeros until we get to this bit right here, which is a 64. The first bit in the 128's position is a 0. In the 64's position, we have a 1, and everything else is zeros. So from that, we know that if we add up the value of all those bits with the host bits set to 0, we're going to wind up with a subnet ID of 192.168.10.64. That's our first subnet. How do we get that? Well, we just set all the host bits to 0. Our first subnet bit is 0. And then we have a 1 here, which is part of the network address. Remember, we've got to take this last octet in its entirety. It starts right there. So the value of that is 64. So let's go ahead and figure out what is our next subnet ID going to be. Since it's also going to be a subnet, let's go ahead and start out with all the host bits set to 0. And we only have 1 subnet bit. So for the first subnet, it was subnet 0, meaning that the one and only 1 subnet bit that we have was set to 0. So the only other value that it could have is a 1. And the remaining bits in this octet, we just have to bring them down because, remember, that's what we were given. They're shaded in red. That's this everything in red here is the /26 that we are subdividing, so we're not changing that. So let's go ahead and write out our next subnet. What's it going to be? Well, how do we know what it's going to be? Well, remember that magic number that we started to talk about. This is the increment by which the subnet ID values increase. And remember that the increment is always going to be the least significant subnet bit, which in this case is the one and only subnet bit that we have, which is this one right here. And if we look, we can see that it has a bit weight of 32. So our subnets are going to increment by decimal 32. So we take .64, which was our first subnet, and we add 32 to that, and that gives us our next subnet ID, which is 192.168.10.96. So how many subnets are we going to have in this case? Well, only 2. How do we know that? Well, we saw in our previous example, we take the number of subnet bits that we have and we raise 2 to that power. In the prior example, we had 2 subnet bits, so 2 to the second power is 4, and that gave us those 4 initial subnets. In this case, we only have 1 subnet bit, so we take 2 and raise it to the first power, and we get 2. So these 2 subnets are the only 2 that there will be. So what is the broadcast number for this first subnet? Well, we can take our next subnet, which is .96, and subtract 1 from that and get .95. Remember that the broadcast is always 1 less than the next subnet. So what's going to be the broadcast for the next subnet? Well, we could take 96 and add to that our interval of 32. That gives us 128. So we subtract 1 from that, and the broadcast for the 96 subnet will be .127. So now that we have our subnet IDs and our broadcast addresses, then figuring out the first and last host for each subnet is easy. The first host in the first subnet is going to be the subnet ID plus 1. That's going to be .65. And the last host in the first subnet is going to be that subnet's broadcast minus 1, which will be .94. The first host for this next subnet, the 96 subnet, will be 96 plus 1. That's going to be .97, will be our first host in the second of these two subnets. And the last host in the second subnet will be the broadcast minus 1, which is .126. And once again, I'm using a little shorthand here, since the only thing that's changing our interesting octet, that is to say the octet where all the action is happening, is this fourth octet. The first three octets don't change, so I'm not going to take up the time or space to write them out. So I'm just writing .65, and you'll know from previous examples that that's just a shorthand for 192.168.10.65 and so on for these other values. So that gives us our subnet IDs, our first and last hosts in each subnet, and the broadcast for each subnet. We should also calculate the decimal value of the subnet mask for this subnet, so that when we get to the point that we're assigning these IP addresses to the host devices, we know what the subnet mask should be. So since the first three octets, nothing has changed there. They're all ones with respect to the subnet mask, so we can write out 255.255.255. And as we said before, the interesting octet is this fourth octet, and that's where the dividing line between these last 5 bits, which are for host addresses, and the other 3 bits, which are for the network and the subnetwork, the dividing line goes right there, and that's a /27, right? So if we wanted to figure out what the decimal value for the fourth octet of the mask is, to put the dividing line right there, we just add up the bit weights of the 3 previous positions. We take 128 and add 64 to that. What does that give us? 192. And then we add 32 to that, and we get 224. So there's the value of the subnet mask that we would assign on the /27 subnets that we've created here by subnetting a subnet. So now that we've created these subnets, what are we going to do with them? Well, what we're going to do is to take this first subnet, this one right here, and we're going to use that as the IP address block that we will assign to location number 1. Recall from our topology diagram that we've seen before, we were required to come up with a subnet for that location that would accommodate 25 hosts. How many hosts can we accommodate here? Well, we have 5 host bits. You can count them right there, 1, 2, 3, 4, 5 in green, so 2 to the 5th is 32 minus 2, and that would give us 30 usable host IPs, which is just perfect for location 1 since our requirement was for 25, and that gives us a few extra. So let's review our progress. So far. We started with the class C, a /24, 192.168.10.0, and we used subnetting to divide that into 4 subnets, the first of which is 192.168.10.0/26 with host IPs 1 through 62. And we assigned that piece of our address space to the LAN, the local area network, at location 2. And just immediately prior, we took the second of those 4 subnets into which we divided 192.168.10.0. The 0 subnet was the first one, 192.168.10.0/26. The next one was 192.168.10.64/26, and we took it and subnetted it further into 2 /27s. And we assigned one of those 27s right over here to the local area network at location 1, and that subnet will accommodate 30 hosts, which is just fine because we need 25 hosts. So now let's turn our attention to taking care of the local area network for location 3, and then finally we'll wrap up by taking care of creating some little subnets for the WAN links between the locations. Okay, so we just took our first subnetwork, the one that we got by taking 192.168.10.64/26 and subnetting it further by moving the mask over by 1 bit. So that leaves us with another subnet down here. And what we're going to do with that one is to subnet the subnet of a subnet. See if you can get your brain around that one. And the result of that is going to be one subnet that we will be using to assign to location 1, and then we will eventually work our way through until we create 3 more small subnets that we'll be using for the WAN links between the locations. So let's go ahead and get that done. Okay, how did we get to here? Well, we started with 192.168.10.0/24, and we divided that into 4 subnets, each of which could accommodate 2 to the 6th or 62 hosts. That was a series of 4/26 subnets, and we assigned one of those in its entirety to location number 2. And then the second one, the 192.168.10.64/26 subnet, we divided it in 2 and assigned one of those, 192.168.10.64/27, to location 1. And here's the other one of those 2 subnets that we created, 192.168.10.96/27. And what we're going to do now is to subdivide it further so that we can have another subnet that's appropriate for location number 3, which you'll recall only requires 10 hosts. And then that should leave us enough to take the remaining piece of the address space that we have and subdivide it even further still to create several small point-to-point networks for our WAN links. So let's go ahead and get started with this. So we were given a /27 to work with, and that's everything that I have highlighted in red. So we're going to move the boundary over by 1 more bit. We're going to move the mask over 1 bit and create a couple of /28 subnets. And we'll follow the same scheme that we've done several times now. Let's go ahead and figure out what are our subnet IDs. We know that subnets always begin with all of the host bits set to 0, so let's go ahead and do that. We've got 4 host bits. 2 to the 4th is 16, minus 2 gives us the ability to support 14 hosts in each of these subnets that we're going to be creating. Location 3 only requires 10 hosts, so that's just fine. That's a good fit. So we've set all of our host bits to 0. There's our one and only one subnet bit because we just moved the mask over by 1 bit. So we're going to start off with our first subnet, and that's with the subnet bit that we have, the only one we have, set to 0. And then the remaining 3 bits in this 4th octet, that's part of the network block that was given to us, so we just have to bring that down. So to get our first subnet ID, and this is going to be subnet 0 for this /28, we'll just add up the bit weights of these first 4 bits here. The 128 bit is a 0, the 64 bit is a 1, the 32 bit is a 1, and the 16 bit is a 0, so that's going to give us our subnet value of 192.168.10.96. That's our first subnet, so let's go ahead and write that down. I hope that we've done enough of these by now that you're comfortable with me writing just the value of the last octet. You're seeing that these first 3 octets, they have not changed since the beginning of our work here. So rather than to continue to just write them down over and over again, I'm just going to write the .96. And you'll know that that is subnet 192.168.10.96/28. So what's our next subnet going to be? Well, we need to find the increment. And how do we find the increment? The increment is the least significant of the subnet bits, the bit weight of the least significant of the subnet bits. We only have 1 subnet bit whose bit weight in this case is 16. So to find the increment, we take the current subnet, .96, and we add the increment of 16 to that. So our next subnet is going to be .112. So what is the broadcast of this first subnet going to be? Well, it's going to be the next subnet, which is .112 minus 1. So the broadcast for the 96 subnet is .111. So what's the broadcast for the 112 subnet going to be? Well, we take our subnet ID of 112 and we add the increment, which is 16. We get 128 minus 1, giving us a broadcast of 127. So now that we know the subnet IDs and the broadcast IDs, it's very easy to come up with the first and last host IP addresses. The first one is going to be the subnet plus 1, that's .97. The last one is going to be the broadcast minus 1, which is .110. The first and last host for the second subnet is going to be the subnet of 112 plus 1, which is 113. That's the first valid host in the second subnet, and the last valid host is going to be the broadcast .127 minus 1.126. So there we have the subnet first, last, and broadcast addresses for the two subnets that we get when we take 192.168.10.96/27 and subnet it further into a /28. We'll take this subnet right here. Remember, there are 4 host bits. 2 to the 4th is 16 minus 2. That would allow us to have 14 hosts. Location 3 only needs 10 hosts. So we're going to take this subnet, the 192.168.10.96/28 subnet, and assign that to the hosts on the local area network of location 3. And before we leave the whiteboard here, we should go ahead and calculate the decimal value of the subnet mask that we'll use on the hosts when we assign those IP addresses over in location 3, which is going to be 255.255.255. We know that, right, because the interesting octet is this 4th octet. These first 3 octets don't change. So the subnet value for each of those 3 octets is all going to be 1s. So 255, 255, 255 dot. And then this is a /28, so the dividing line falls right in the middle of that 4th octet. We've got 4 bits to the left and 4 bits to the right. So to get the decimal value of the last octet of the mask, we simply add up these values. 128 plus 64, that's 192, plus 32 is 224, plus 16 is 240. So 255, 255, 255.240, that's the decimal subnet mask that will be assigned to the hosts when we use these IP addresses .97 through .110 in the 192.168.10.96/28 subnet, which will go on the local area network of location 3. Okay, let's quickly review how we got to where we are. We started with that 192.168.10.0/24 network allocation that we were given, and from the networking topology diagram, we had those 3 locations, each requiring a different number of host computers. We had location number 2 that was the largest location. It needed 50 hosts, so we determined that we needed 6 bits for the subnet to accommodate 50 hosts. We actually wound up accommodating 62, so that allowed us to take that initial allocation, which was a /24, and subnet it as a /26 using 2 bits for subnets, giving us 4 subnets, each able to accommodate 62 hosts. We took one of those and allocated it to location 2, and then the second of those /26 subnets, that was 192.168.10.64, you'll recall, we subnetted it further by moving the mask over 1 more bit, and that gave us 2 subnets, 2 /27s, one of which we assigned to the local area network at location 1. We took that /27, and divided it into 2 /28s, one of which we assigned to the local area network at location 3, and the other one is the one that's on the whiteboard, the 192.168.10.112/28 network. That's the second of those 2 subnets that we had, one of which we assigned to the local area network at location 3, and this is the other one that we're going to subnet still further to create at least 3 small subnets capable of accommodating 2 hosts each, and we'll assign those to the WAN connections between the 3 locations. So let's take a look at what we have here. Recall that we do have 3 locations, thus we need 3 wide area network links. That means 3 subnets. How many hosts do we have to have on each subnet? Only 2, because these are point-to-point WAN links. A router interface on each end, that's what we're going to do with those 2 host IPs. So 2 host IPs are plenty. But the critical thing is we've got to have at least 3 subnets because we have 3 WAN links. Well, look what we've done here. We've got a /28, and where the red stops and the yellow starts, that's the 28/28. That line is right there. So we've moved our line over 2 bits this time. We've got 2 subnet bits, where the last couple of times we've only had 1 subnet bit. This time we've got 2, and that gives us 2 to the second power, or 4 subnets, each that can contain 2 to the second power minus 2, or 2 hosts, which works out just perfectly. We'll have 1 extra subnet that we won't use, but this will give us the 3 that we need. So let's go ahead and figure out what the subnet IDs are going to be. First host, last host, broadcast, and then we'll figure out what the new subnet mask is going to need to be configured on the router interfaces when we actually put these networks into place. So what is that first subnet going to look like? Well, the first rule of coming up with subnets is that the subnet ID is defined as that value which the host bits are all set to 0. So we have 2 host bits, and I've set those to 0. We also now have these bits that are highlighted in yellow. These are our subnet bits, and we're going to start with both of them set to 0. This will be our subnet 0. And then over here, this is the /28. So from here back, we're not going to be changing any of that. So we just bring all that down. And that's the 4th octet. That's the first subnet in the 4th octet. So to figure out what the value of that is, we need to come up with the decimal equivalent if we add all these bit weights together. And since this is subnet 0, that's the value right there. We take 64. The 128 bit is set to 0, so we take 64, 32, and 16, add that together, and we get 112. We knew that already. So the first subnet, or subnet 0, is going to be the 112 subnet. So once again, I'm just going to use my shorthand and write the final octet there. We've done this enough now for you to be realizing that 192.168.10, that's been the same all the way through, so I'm just going to write 112, which is the last octet. So what's the next subnet going to be? Well, it's going to be the current subnet plus the increment. What is the increment? Well, the increment is always going to be the bit weight of the least significant subnet bit. So right here, these are our subnet bits, and we can see that the bit weight for the rightmost, or the least significant subnet bit, is a bit weight of 4. So our networks are going to, or our subnetworks rather, are going to increment by 4. So the next subnet will be .116. How many subnets are we going to have? We're going to have 4 because we've got 2 subnet bits. 2 to the second is equal to 4. So the next one, 116 plus the increment, .120. The next one after that, .120 plus the increment, which is 4, .124. And those are our 4 subnet IDs. Now let's figure out what are the broadcasts going to be. We know that the broadcast for the current subnet is the next subnet minus 1. So the broadcast for the 112 subnet is going to be the value of the subnet ID for the next subnet, which is .116, minus 1. So let's go ahead and write 115 up here. For the 116 subnet, the broadcast is going to be 119. For the 120 subnet, the broadcast is going to be 123. And for the 124 subnet, we can take 124, add the increment, which is 4. We get 128, subtract 1 from that. So the broadcast for that final subnet is going to be .127. First host and last host is easy. The first host is the subnet plus 1. The last host is the broadcast minus 1. So 112, the first host is .113. Broadcast is 115, so the last host is going to be 114. Same for the next one, 116. .117 is first. .119 is the broadcast, so .118 will be the last. .120, so the first host will be .121 for that subnet. The broadcast is .123, so the last host will be .122. For the final one, .124 is the subnet. First host will be .125. Broadcast is .127, so the last host is .126. So there are the 4 subnets, and we'll only use 3 of them. We've got 3 point-to-point wide area network connections. We've got 4 subnets here. We've got an extra one. So let's figure out what is the value of the mask going to be. Remember, we started with the /28. That's where the red stops and the yellow starts. That's the end of the network that we were given to subnet. There's our subnet bits. So where is the subnet mask going to be for each of these subnets that we've just created? This is going to be what? A /30, right? Because we started with /28. We borrowed 2 of the bits that remain there for subnetting. That leaves us with a /30. So the mask, the decimal subnet mask for a /30 is going to be 255.255.255.252. How do we come up with 252? Well, we just added up all of the bit weights. 128, 64 is 192, and 32 is 224. 16 is 240, plus 8, 248, plus 4 is 252. So there's the decimal subnet mask that we will be configuring on all of the router interfaces when we apply these IP addresses in the configuration. So to complete our topology diagram and to complete our IP addressing plan, we'll just need to take these 3 subnets. We'll take this one and assign it to the link between router 1 and router 2. We'll take the next one and assign it to the link between router 2 and router 3. And then we'll take the last one. My highlighter kind of got off track here, but the 120 subnet, we'll use that on the link between router 3 and router 1. So let's go ahead and complete our diagram. So here we have the networks applied to the WAN links. Here's the link between location 1 and location 2. That's 192.168.10.112. 192.168.10.116. That will be the link between location 2 and location 3. And then the location 3 to location 1 link will be the 192.168.10.120 subnet. And notice these are all /30s with a 255, 255, 255, 252 decimal mask that we talked about. And since they are /30s, that means that we have 2 bits for host addressing, and 2 is exactly what we need because we get 2 to the second power is 4. And even on these little point-to-point links, we still have to subtract 1 for the broadcast and 1 for the subnet, leaving us 2 assignable host addresses, and that works out just the way we want. So there we have it. To summarize what we've done, I've put together this graphic that hopefully will give you a picture of how we've taken our initial allocation, which is that 192.168.10.0/24 network represented by the larger green block, and we use subnetting to take 2 of the remaining host bits in this /24. We move the mask over, subnetted to a /26, and we use those 2 subnet bits to create 4 subnets from 192.168.10.0. And there they are. I've numbered them 1, 2, 3, and 4. 192.168.10.0/26, 10.64/26. And these 2 down here at the bottom, notice that we didn't even use them. Those are /26 subnets, the 192.168.10.128 and the 192.168.10.192 that remain for future use because we've been efficient in our use of this 192.168.10.0 and used only what we needed for the size of the subnets and the hosts on those subnets that we have. We've got surplus address space that we could use for other purposes. So we took that first subnet, as you'll recall, and assigned that to the local area network at location 2. Then we took the second subnet and subjected it to further subnetting. This is where we subnetted a subnet. We took the 192.168.10.64/26. We moved the mask over 1 bit and broke that down into 2 /27s. The first of these /27s we assigned to the local area network back at location 1. And the other /27 we subjected to further subnetting. We moved the mask over 1 more bit and took that /27 and broke it down into 2 4/28s, the first of which, 192.168.10.96/28, we assign that to the local area network of location 3. And that left us another /28 remaining, the 192.168.10.112/28, and we moved the mask over 2 bits in this case because we needed at least 3 subnets. 2 to the second power is equal to 4, giving us 4 subnets, and we only used 3 of them. So we took this second /28, the 192.168.10.112/28, and we broke it down into 4/30s that we used 3 of for the WAN links between the locations. This last /30, we didn't use it. So this is the way we assigned our /30 subnets for the WAN links. The first one we used on the link from location 1 to location 2. The second we used from location 2 to location 3. And then the third we used from location 3 back to location 1. So that's just another way of looking at what we did, and maybe a little more concise way, so that you can see how we've developed this hierarchical use of IP addresses where we took a larger subnet or a larger network, the /24, and started breaking it down into subnets to meet the needs of the network topology that we have. Now, this has been a subnetting how-to, and I've gone through everything in a fairly detailed and methodical way, taken some time to do so. In our next video in this series, I'm going to show you how to speed the action up a little bit, and we've entitled that presentation Fast Subnetting, where I'll show you some shortcuts to help you speed up your work and save some time as you're working through these types of problems. So be sure and check out our next video entitled Fast Subnetting.